These are the topics that I'm going to cover. I mean, the agendas that I'm cover. What is ERC 6551? And then I will give a brief demo. What is it about? Then I will talk about some use cases, and then we will talk about the proposal itself. It is still an ERC in review stage. So I will talk about the what was actually proposed by this ERC, and then talk a little bit about the ecosystem right now and the adoption about it. So, what is ERC 6551? Okay, if you okay, first I need to just mention the authors. Jaden Weindel and Benny Diang, they are both from Future Primitive. So they are the starters who initially proposed this particular approach to enable NFT to bound to an account, right? So they are the original authors, but over time there are a number of people join in as an authors where they share different approaches and enhances the approach for this ERC. So that's why the authors this grow, right? Okay. So what is ERC 6559? 6551. ERC 6551 enables NFTs to have their own wallets. So that's the just one-liner to summarize the entire ERC. If you just want to know the overall about this ERC, this is it. This is just that one-liner. It enables the NFT to have their own wallet, right? So when we talk about wallet, what do we mean by wallet? We I think everyone knows that in Ethereum we have two types of accounts, right? We have UA accounts, we have a smart contract accounts. So when we talk about wallet, it's actually the smart contract wallet, and in our context we name it token bound account. The token bound, the token refers to the NFT, and the account, it means this account owns by or attached to an NFT. So in short, we call it TBA, token bound account. So what does this TBA allow NFT to do, right? TBA is a smart contract account. It's just like an EOA. So whatever you can do with a EOA account, you can do with TBA. So you can own an asset uh, in this account, any asset. It can be ERC20, it can be 721, and it can be 1155. If you look at this 721, 721 is also an NFT. So that means that an NFT can own a token bound account, and in turns that this token bound account can also own another NFT. So the cycle goes on, right? The hierarchy goes on. So it's a chain of ownership of NFT all the way down. Right? It can be NFT or it can be anything at all, any asset that can be owned by a Ethereum account. So besides owning assets, the TBA allows NFT to also execute transaction. Because this is just a normal Ethereum account, you can execute transaction with it. You can also deploy contracts with it, and it can also have its own transaction history. So this means that we enable the NFT to not only be just a JPEG within your wallet. The whole NFT now become like a person, right? Like a person who can own assets, who can execute transactions, all that things that you do, right? So it's a powerful enablement for NFT. So because of this, a lot of people was excited to trying to put this ERC into their dApps and use them to actually enable a lot of new use cases. So okay, I want to talk about the design criteria. So the original team they have considered a lot of criteria for this particular ERC. The first one is backward compatible. So this ERC is deliberately designed to work with all existing NFT. That means any NFT currently on chain, on any EVM chain, there's no modification to the contract needed. So by default, all NFT in existence has already have an account. So that is by design. Okay. The second thing is about the design criteria is that it has to work well with the existing platforms like OpenSea, MetaMask, Etherscan. Yeah, because as I mentioned just now, the token bound account is just a smart contract account, and that is a account model that is well understood by all these platforms already, right? And it is designed to be fully decentralized. NFT has full custody of the TBA. Yeah. So that's just a brief overview about what this ERC is about. So next, I wanted to show you a little bit from the visual perspective. How can you see the NFT? All right. Okay. Give me a second. All right. Okay, I want to show you this page, right? This page is, I think, familiar to many people. This is OpenSea, and this is the testnet. This is in Goalie. Okay, this is the artwork created by one of our ETH Penang member. Okay, I uploaded this NFT to one of the NFT contracts, and then I show it in OpenSea here. And this is just a normal NFT, but I have actually used this NFT to create an account, to deploy an account, and I also send two NFT into that account. So how do you see it? There is a button here, and when you click on it, you will see there's two additional NFT here, right, under this collectible. That means this original NFT, this one, now owns these two. And besides owning another 721 NFT, you can also own assets. That means you can have Ethereum or any ERC standards token that in existence. You can actually send it over to this TBA, the token bound account, right? So this means that this particular main NFT now owns assets plus also owns the tokens. You can do that. So if you take this URL, you open up a new tab and you replace this with tokenbound.org, right? So this is a site created by the original authors, and you will be able to see that this explorer that was developed the um, by the token bound team, and they created explorer to let you visualize what you have in your NFT. So you look, if you can see this account, this is the token bound account address that belongs to this NFT itself, right? And also you can see this NFT also own this asset 0.001 ETH. So this is the whole thing about this ERC. It gives this NFT the ability to own additional assets. Yeah. So back to my slides. I will cover some of the use cases. So why do we want our NFT to custody assets? Why? What is the significance of it? Right? What benefit does it bring? Right. Okay. The first one is airdrop. Right. So we used to airdrop to an account, right? A normal account, but with this ERC, you can actually airdrop something to NFT. So by having this NFT, all the NFT by having this ERC, all the NFT in existence by default already comes with an account. So you can directly airdrop any tokens to an NFT because by default every NFT has an account. So imagine last time when you are planning for an airdrop, you are collecting all the dynamic addresses from the owner, right? So instead of doing that, you can actually directly compute the NFT address and directly airdrop those tokens into the NFT TBA account. So it simplifies the entire airdrop processes, right? Okay, the other use cases is that now you can log in as a NFT. Um, we, we used to log in using our own account, right? And using MetaMask or that kind of things. But now you can use the NFT that you own to represent as yourself, right? You can imagine it as a character that belongs to you. Probably you can have maybe multiple characters that represents you for different scenarios, right? But let's say you're a game when you are a gamer, you can use one of your game NFT to be yourself and log in using that particular NFT. But when you are at work, right, you join a certain DAO, right? You can use another NFT to represent you and use that NFT to log in to be you, right? So this is another of the use case because we cannot do this earlier because NFT is not an account, but now NFT is. So the third use cases is that probably in the scenario where you have a vault and the vault is generating some yield for you over time, right? So we used to be joining certain vault using our own address, let's say, for example, and we have collected quite a number of yields over time, right? And or NFT over time, right? What happened if you want to sell or transfer those yield that you collected in the vault to someone else? So we used to just make a transaction from our own account to the other person who wants to buy it from you, right? But now that you can use NFT to represent yourself, you can use your NFT to join the vault, and ultimately all the yields will go under the NFT, and you can later sell your NFT to another party, and automatically whatever comes under that NFT will be transferred over to the new owner. So you don't really need to sell your account by sharing your private key to the new buyers because you can transfer the whole NFT ownership to the new buyers and you keep your own private key to yourself. Okay. The fourth use cases is like gaming profile. So imagine you're a gamer, you are very good in gaming and you collected a lot of armors, weapons under you, right? In the past, all those goes into your address, your account. But now you can join the game using an NFT, and all those weapons, armors goes under an NFT. And you can actually opt to sell your NFT by directly transferring the NFT out to the new buyer, and everything's go under the NFT will go in one shot. So this is why it is very powerful. You can't do this before this ERC, right? We can do the same thing for social media. You can build your portfolios or reputation in your social media, and which comes with an value, and you can transfer that value to a buyer. And you can also use this NFT to sign in as a signer for a multi-sig. Because the TBA, the token bound account, is just a smart contract account. You can use it to sign an NFT and a multi-sig. And you can also use it to control an ENS name. So these are just a couple of use cases that this ERC enables, right? So I'm gonna stop here, and if you have any questions, you can ask, because whatever comes next is more for technical people or for developers. Is there any question? I think you can unmute yourself if you want to ask question. How does NFT sign messages? You are using the token bound account that attached to the NFT to sign messages. The question is related to what tool you use to sign, or or does my answer just now answer your question? Yes. The token bound account is just a smart contract account. You can imagine it is like your 4337 account, right? And you can use your 4337 account to sign transactions. It's just like your EOA. You use MetaMask to sign the transactions, but you can also use the regular tools or your codes to connect to that particular token bound account to make a transaction. Uh, that okay. It depends on what you want to do with this ERC. For sure, this is an additional work that or additional things that your debt needs to handle. But do you the I think the right question to ask is why do you want to adopt this particular ERC? You would want to adopt this for certain purposes, right? So you if you have decided that these particular features is needed within your dApps, definitely you need to conform to the standard defined by this ERC. And of course, that will add complexity to your dApp. So it all boils down to what you want to use ERC 65514 for, right? There are all these use cases, right? Um, uh, let's say there's a game that wanted to use this 6551 as the mechanism for them to hold a gaming profile, right? So of course, this particular gaming contract will add complexity because they need to be conforming to this 6551 proposal. I would say, of course, it will definitely add complexity, but that will benefit you because that is the features that you want to add into your dApps. Is there any other question? Okay, all right. Let's talk about the proposal itself, right? So how does this ERC 6551 enables any entity to own other assets? How do they do it? What was the proposal about? So the proposal involved three parts. The registry, there's a registry that they are proposing, and there's an account interface, and there's also a proxy. So by combining all these three, they enables the NFT to own an asset. So let's go deep down into it. Okay, this particular diagram should be very familiar with if you have read some of the materials online about 6551. So this summarizes the entire parties or entities involved in the entire flows, right? So let's look at the left-hand side. So we have the regular NFT here, 721 NFT here, the contracts. So this is one contract A, this is one contract B, and contract A has a token 123, contract B has token 456. So as usual, these contracts, this token belongs to certain users. It can be belongs to certain users. And this user account, most of the time is EOA, will own this token, right? And as part of this until here, these are the regular things that everybody is familiar with, right? But under this proposal, the ERC proposal, they are adding this registry there. This registry is a contract that allow NFT to deploy a token bound account. The accounts here, account ABCs here, these are the token bound account. So the registry can actually create all these accounts. The token owner can instruct the registry to create all these accounts. These are what we call TBA. But this TBA is just itself is a proxy. It's not the actual um, account implementation. The account implementation is here. So you can imagine that the real account contract sits here at the implementation part. But what this registry creates are just proxies to this real implementation. That means you have this account A. If someone make a call to this account A, the call will be redirected to the actual implementation, right? So if you look at these scenarios, right, we have one B implementation, but this B implementation is being proxied to by two different TBA. So you can have the same implementation being shared across two different TBAs. So this is possible. This is the whole purpose of this TBA. The TBA is supposed to be lean, supposed to conform to the interface for it is lean is a proxy to the actual implementation at the back. But this TBA is itself a smart contract wallet. Does that is it make sense, or is there any question? Okay, this users here owns the token here, but this token owns the token bound account here. So indirectly, this user controls this token bound account. So if this user transfer out the ownership of this token to somebody else, anything under this token, this token, anything under it will go together to another new buyer, new persons. Yeah, let me move on. Okay, this is the interface defined by these ERCs, right? There is a registry interface. What this registry does is that it allows you to perform two actions. One is to create an account. When I say create an account means this action. This registry can be called by a person, the owner of an NFT, to deploy an account. So when you can do that by calling this method and putting in the implementation address, chain ID, token contract and ID. These three parameters, chain ID, token contract, and token ID, will uniquely identify any NFT on any chain. Just these three parameters. And you will have a seed parameters where you can define different values. This seed allows each NFT to own multiple token bound account. So that means, okay, if I go back to the slides, right? You look at this token. This token has two lines here. So this one NFT owns two token bound account. How can it own two account? You can own two account by putting in two seeds, different seeds. You can put 0 for the first account, and then you can put 1 for the next account. Then it enables an NFT to have unlimited number of account, right? And this init data is just something that you send in to initialize the token bound account, right? The second function is just a view function. It allows you to retrieve to compute the end account address. So what the account address for, okay, let me go back to this. The account address for this token is deterministic. That means you do not actually need to create this account, but you can already transfer to a asset into that account. So that means today, let's say today in your wallet, you own an NFT. You actually do not need to create any account. You can directly send any asset into the TBA address. The TBA address does not need to exist. It can be in counterfactual state, but you can already transfer token into the account. But only when you wanted to perform certain actions with it, then only you need to create the account by calling the function inside the registry. So I hope that makes sense to you. So the as part of the ERC, they are proposing a singleton, permissionless, and immutable registry. So that's their proposal, but they are not stopping you from deploying your own custom registry. But this proposal is stressing that the importance of having a singleton one, because that promotes the trust among all parties who would adopt this particular ERC. So that's why we have a canonical registry. If you look at this link here, the project team already create all this registry in all this chain here. You can notice that they're all having the same address account, because this registry contract is created by the create2 opcode. So they can all have the same address across different chain. So if you're a developer in another chain that is not here, you can actually take the registry implementation from their GitHub, and you can actually deploy it to the chain that you want it to exist. But you can also work with the project team to get their help to deploy this registry for you in the chain that you are working on. So for now, the registry address for this for the current state all sits here, but please be reminded that these addresses are going to change, because this ERC itself currently is in the review state, and and there's a lot of changes that are being added and made every now and then. So right before it is finalized, the project team will actually redeploy the canonical registry contract to the chain, and this address will change. So you can use this address for now for your own testing, but ultimately when they finalize the ERC, this address will change. You just have to take note of that. And okay, as I mentioned, this method create the TBA, but this TBA is just ERC 1167 proxy. It's just a proxy. That delegates all the execution to the actual implementation, which means this, right? This is just a proxy, and all the calls to this proxy will be delegated to the actual implementation here, will be executed. The logic will sit here, but the storage sits here. Okay. Okay, it can be deployed to any chain at a known address. This is what I mentioned just now. And this particular registry interface also support cross-chain compatibility. So you can have a scenario where you have an NFT in one chain, but that NFT is controlling another TBA on another chain. So imagine you have an NFT on Ethereum mainnet, but that NFT has a utility on, let's say, Optimism. You can actually use the NFT on main chain to do a vote. Let's say you're part of the DAO, you can do voting in another chain, like for example, Optimism. Yeah, this is possible. And this has already been implemented in their sample implementation in their GitHub. You can have a look at it. Okay, let's move on. Another interface that is proposed by this ERC is the account interface, right? This account interface refers to the interface that needs to be implemented by this account here. Okay, it has a couple of function or method. The first one is receive. The receive is to receive the ETH sent into this account. Token is to give you the information about the original NFT that owns this account. So it gives you the chain ID, it gives you the NFT contract address, and it gives you the token ID. So these three uniquely identify a single NFT. Okay, there's a method called state. So this state is something that the marketplace or the dApps needs to use um, to to indicate there are some state change within this account itself. So the purpose is to prevent fraud. I will cover the fraud later in the later slide. So there are some scenarios where you can rob another person if we do not implement the relevant check that is needed. And there's a method called is valid signature. So this is a new enhancement. We used to have something called owner method here to indicate who is the actual owner of this account. But over time, the proposal changed. Now they become is valid signer. So as I mentioned here, this is valid signer is here to make the whole proposal more generic, to be able to support some other NFT standard that doesn't have a single owner. So when a single owner, a canonical owner, that when I say single owner means if you look at 721 ERC 721 specs, right? Each NFT is owned by just a single owner. So that is very clear cut. But if you look at the 1155 contracts, right? It's a semi-fungible. So each token ID could have multiple count of it. There's multiple supply of a single token ID, and they can belong to different owners. So it doesn't fit the paradigm of this particular proposal, because we need to be able to uniquely identify who is the owner, this token, who is the owner of this account. We cannot have multiple tokens owning a single account. So the reason why we call this token bound account, because it has to bound to one token, not multiple token. So that's why this particular method signature is very important. It opens up the possibility for other specs to adopt this ERC as well. Yeah. I think I don't want to cover the rest. Let's save some time. And okay, they also proposed another executable interface, which is also something new. They just added in like a couple of weeks ago. They want to enable the account to be able to execute any arbitrary execution, right? So this execute used to be inside here under the account, but they extracted it out to become a standalone interface, because there is today there is not a uniform method signature for calling execute on a smart contract account. So if you look at the Gnosis Safe, right, they have their own standards of executing. If you look at other 4337, let's say, you have another method signature for execution. Maybe you can look at Argent. Maybe Argent has another execute method signature. So they are all different, and there's no standardization today. So that's why for ERC 6551 today, they are proposing this signature, this method signature, and extracted it out into a separate interface. So as part of the spec, you must implement one execution interface, not necessarily this one. You must execute one, but it can be this one. Yeah. All right. If you are developers, there are a couple of things you need to take note. You have to be aware that the NFT can be deeply nested. NFT can own another TBA, which in turn can own another NFT, can own another TBA again, and the cycle goes on, right? If your debt do not want to support the deeply nested NFT, you need to build the custom logic into your account implementation, right? And ownership cycle is something that you need to take note for certain marketplace. Let's say, for example, your debt do not want the NFT to be burnable, right? So when I say a ownership cycle means an NFT A can own TBAA, and this TBAA can own NFT B, and this NFT B can own another TBAB. But let's say the owner of the top level NFT transfer the ownership of that NFT to TBAB. So that become a cycle, right? So when it become a cycle, that means nobody owning anything. So in a sense that you are actually that transfer action is actually burning that NFT itself. So burning not only the NFT, and anything comes under the NFT that are all they're all burned, inaccessible later. So if your debt do not have the need for burning, you need to particularly check the transfer action, make sure that it is not transferring to any of the sub TBAs. Okay, fraud is something kind of like possible if we are not careful. So imagine that you have an NFT, and under that NFT you can own a lot of other NFT and also assets, and that your NFT is very valuable. So maybe you decided to you are a malicious person. You want to sell this NFT in the marketplace, but you want to rug the buyer, right? You can actually list it in the marketplace and wait for a buyer to make a purchase, right? So and then you can actually work with the miners or the validators, or you craft a flashboard bundle to front run the particular transaction, the purchase transaction, right before the buyer purchase your NFT. You actually move all the valuable asset under the NFT out to a separate account. And what that buyer eventually gets is just a top level NFT and nothing underneath it. So you can actually do this kind of fraud today using this ERC. Uh, if if the if the marketplace does not actually check for this. So that's why I did mention a function called state, right, under the account interface. That state can be leveraged by the marketplace to make sure that when somebody lists the NFT for sale, you need to record down the state and make sure when we perform the transfer, the state is still, there's no change of state in that account. Yeah. And the last one is also this is similar to the fraud one. So you have to make sure that for those account implementation that approve that has some approval mechanism built in, right? So you can have the account implementations approve other address to perform transaction on the TBA. Not only the owner of the TBA can perform a transaction, the owner can delegate that rights to another party to do the transactions. This is a valid scenario. So if the marketplace wanted to be safe, you need to check whether the owner actually delegate the execution right to any other parties before you do the token transfer. Yeah, this is also security consideration lah. If you do not want your marketplace user to get wrecked, I mean robbed by the original NFT owner, the malicious user. Okay, this is worth mentioning. The cross-chain NFT, I mentioned it briefly just now. So an NFT can exist in one chain, but can also have the TBA across a different chain. So this is implementation dependent. So some of the dev can have the use cases like this. They can use the bridges or some message passing mechanism to allow the cross chain communication. So out of box today, if you go to the GitHub to look at the source code, right? Out of box, it is already supporting OP stacks. So that means you can have an NFT on Ethereum main chain, but this NFT can actually make a transaction to a TBA in any OP stack. So it's a cross-chain execution. So it's already supported out of box. Yeah. Okay. Let's briefly talk about the ecosystem. I think I don't have much time. We'll go fast. There's somebody's called Sky SKE. He has put together the ecosystem map here. So you can see a lot of projects starts adopting this standard because it is very different from what we have in the past, and it can support a lot of use cases, right? So one of it is Gnosis Guild. Gnosis Guild is a open source tools to support DAO, right? They actually adopted this ERC 6551 as part of their Mac offering. Their Mac offering allows uses standard to allow NFT to hold the assets in the DAO. Another one is Lens protocol. I think everybody knows about Lens. Lens built in support for 6551 in their version 2. Yeah, to enable people to enable the profile, the Lens profile to hold the means or the collects under the TBA rather than under the original address, the owner address, to ease the future transfer of those assets. OpenFort is a wallet as a service uh, company. They are combining 6551 with 4337, the account abstraction tools. They are offering their wallets with the feature of 6551. Pinata built an application that helps us better visualize our tree of ownership for NFT and the TBAs. So if you're interested, you can go to this link here to see the tree of ownership. Yeah. Adoption. This is the Dune Analytics. I just pulled this yesterday. So if you can see, the proposal starts to become active somewhere around May this year. So a lot of discussion, a lot of people got to know about this 6551 and they are excited. A lot of people start building application using these standards. As of yesterday, there are about 12,000 ERC 6551 account being deployed on all the EVM chain. So there's about 1,000 over transaction happening there. So this number continue to grow. There's a lot of people starts to think about how can they adopt this into their protocol. I think that's it. That's the last of my slides. Is there any questions? You can unmute yourself to ask. No question? Okay. Thank you, everybody.